Hello everyone. So we'll start our new subject, that is structural engineering. This has around some weightage. What is the weightage of the subject?
I think 10 to 14.
Yeah, it is 10 to 15 marks. As we have said, now FE handbook is 10.5 version. In the last few pages, you can see the syllabus for civil engineering. There, in the subject 11, serial number 11, they have mentioned structural engineering, whose weightage is 10 to 15 marks. So 10 to 15 marks. So what is the weightage in percentage? If you take an average, let us take it as 12. What is the percentage?
9%.
9%. So 12 marks by, what are the total marks for FE? Is it for 100 or something else?
120.
110.
110.
Yeah, it is for 110 marks. So 12 by 110. So this value is it 90 or 90 point something? You have to tell me, then only I draw. Do it in your mobile or something somewhere else. Tell me the percentage exactly.
10.9. 10.9.
10 point, okay, 10.9 percentage. So if you cover this one single subject out of 14 subjects, you will cover almost 10% of the marks for sure. So it's a very important subject. So please be very careful. And it will be not only helpful for FE, it will be helpful for your MS subjects, so and so. So listen to this carefully and attend all the live classes. So coming to the subject, in today's session, I will teach what is there in the syllabus, what exactly is structural engineering, what are the things to give importance on what are the things we can neglect. Yes, we can proceed now. So tell me, guys, what is this structural engineering? What is the definition of this subject? What do we do in this? Just random guess.
Focusing
The
on
basics
designing
of
and analyzing the structures.
Calculate the loads applied on the building.
Okay, the first one is focusing on
Designing and
analysis.
analyzing the structures.
Did you use AI? I just saw this word focus on AI just now. Okay, that's right answer. Focus on analysis and design of structures. Someone else, something else. What is that?
Load analysis.
Okay, pretty good answer. Load analysis.
Factors that affect the structural.
Okay, factors that affect structures. Perfect. This is also right answer.
That includes
Okay.
sway and movement of inertia.
Yeah. Okay, that includes moments, so and so. Moment of inertia is saying okay. Anything else?
Making the
Type of
structural
loads.
economical.
Calculating
Mhm.
shear force bending moment for the beams and doing analysis.
Someone said very good word, that design. We
Economical.
have to do economical design. Okay.
It
And
also
someone,
focuses on the safety and the stability of the building.
perfect. Safety and stability. That's a pretty right answer. It is also very
Desi-
much
Designing
yes,
based on the standards.
pretty good. We have to Okay, we have to design, that's right, but we cannot design on our own. We have to follow some standards. Like in India, we have IS codes like 456, so on, so 800. There we have American standards. So we'll see what are the standards involved in US and what to follow. And yes, you guys have given
And also about
mm,
the selection of the materials.
perfect selection of the material type, whether it has to be concrete or steel or something fiber reinforced concrete, so on so. Yeah, selection of materials. Yeah. So anyone want to say something else? You can proceed. We have got plenty of points about the structural engineering. Okay. Here I see some standard words like I see the word analysis, and somewhere I have seen the word design. And someone said as economic design. So, what is this analysis? What is this design? Are the same or something different?
Different.
Different. So basically, structural engineering, it focuses on the design and analysis of civil engineering structures or any structures to resist external loads so that they will be stable, they will be strong, and they will be durable. If they are stable and strong, but just the building stays for 5 years, it is of no use. Even for constructing a building, it takes 2 years. If it is designed for just design life for 5 years, it is of no use. It must be durable, it must be strong, and it must be stable. Now, this is called structural engineering. It's, as I said, it is nothing but it focuses on design and analysis of structures so that they are stable, strong, and durable. Now, my question for you, you guys will pretty well answer it. What is difference between a stable versus strong? Are both the same?
No.
Yes, no.
Stable means it would resist the wind or probably the earthquake movements, and strong is the strength against
Yes.
the load.
You guys are almost near. The strength, the stable is something related to movement. Am I right? And
Yes.
strong, that the strength is something related to load bearing capacity. You can see in the recent news, even in the Russia, earthquake has happened recently. Of what magnitude? How much magnitude it was?
7.6.
7.1.
I guess it is 8.8. It is some highest magnitude.
8.2.
Okay, it is 8.2. So in such high magnitudes, suppose there was a building, there were no casualties in the Russian earthquake, but suppose if it was a multi-story building and the building they have constructed it very strong. They use M40 grade concrete, they use high strength steel, so on. So they did lot of efforts. But what they did not worry about the soil on which they constructed. Suppose this is the soil in which they constructed the building, where they laid the raft foundation or so on. So now earthquake has come. After the earthquake, it will transfer the base shear. This shear will transfer to the top. If the soil is not, you know, well confined, if it is not dense, even though no matter how strong you construct the building, because of the earthquake, because of the vibrations, this building will just topple like this. Entire building will stay intact, but the building will fall away. Instead of breaking, it will overturn. So this structure, we call it as unstable structure. It might be strong. I agree. We agree it is strong. They use a lot of good quality materials. The superstructure design was very good, but they neglected substructure. Because of this, the entire structure moved as a whole. So this is the difference between stability versus strength, or stable versus strong. So this is one practical knowledge you have to know. So the structural engineering will design, analysis and design the structures so that the structure is stable, strong, as well as the third thing. What is the third thing? I said just now. Are these two more than enough? Yeah, it must be
Durable.
durable. Okay. So in present day design and analysis, can you guys tell me for how many years we are designing a multi-story building or a bridge or a dam? Any guess?
30 years.
How much?
Structure
30 years.
for, I mean,
40
Yes.
to
Yes, you guys are
125
right.
years.
Yes. Actually, it is varying from 40 to 50, 75, 100, maximum 125 years, but not beyond those. But when you see the structures constructed by our ancient Indians or Romans or so and so, any other civilizations, they are still intact. They are living for around 500 years. Even if you see the Harappa Mohenjo-daro civilization, it's like They're thousands of years ago. So the design plays a major role. Someone has started the double two devices. I guess I'm getting my own voice. Okay. So based on the design life will be fixing. So that's all about structural engineering. Now let us go a bit deeper. I will say the subject structural engineering for FE exam. Okay, we know it is having 10 to 15 marks. I agree. It is in practice divided into two parts. The first part is structural something, and this is structural something. What are these things?
Structural analysis.
Analysis and design.
Yes, one is structural analysis and another is structural design. So you guys tell me, what is the difference between these two? What we do here, and how they are correlated? Tell me your answers.
In the structural analysis, we analyze the structure, like what are the quantities we needed and all those stuff, like what kind of load it is. In the
Mm-hmm.
design, we provide the like bars, like we strength its life
Number of
with
stirrups
respect
used,
to analysis.
number of
Analysis, I believe, would be understanding the movement of the structure. Design is developing the structure, how much load it could withstand.
Okay, you're right. Any other answers?
Like
Basic
Hmm.
in the structural
analysis is
analysis, we calculate like the loads, what are the moments acting
Mm.
on like the beams on the structure, and plus
Mm-hmm.
like the bending moment and like the shear
Mm.
force. With the help of the
Mm.
bending moment, we designs like the beam. With the help of like the shear force, we design like the columns. So
Mm.
on. We are just analyzing for the structure.
Okay.
uh,
Yes.
I would say
Proceed. Yes.
analysis is in the sense like what is the structure, how structure will behavior like when we keeping the loads in a different sizes and different members. Based on that, and then we'll do the design, what member it gonna be, what size it gonna be.
So you're saying it is behavior under loads. If you want to study the behavior of a structure under the loads, we call
Under
it
different
as
loads.
yes, under loads. It can be different loads, combination of different types of loads. So in general, under the loads, how the structure behave or the react or respond. If you study that, we call it as structural analysis. Coming to the structural design, now for the behavior, suppose for a given load, it has undergoing some bending, some torsion, some twisting. So for that effect of that loads, if I want to make the structure stable, strong, and durable, so what is the material I can use so that my structure gonna be economical, and what should be the size I have to use so that my structure gonna be safe and economical. So here, what we do, we'll design the material, we'll choose which material so that it will be safe and economical, durable, so on so. And what is the size of the material to pick up so that again it will be stable, strong, durable, safe, economical. There are like, 5, 6 factors. So this is the difference. I will give you best analogy. Suppose you have moved from India to US or some other country to US. You have joined in some college and you have taken some sharing room and you would like to buy a chair. So chair, is it a structure or not? Practically.
Yes.
So chair is a structure. Suppose your weight is around 70 kgs or something in pounds. It will be more like 100 or 110 pounds. And you went to a furniture shop and thought to buy a chair. So when you went there, the seller will definitely ask you for what weight of a person you would like to buy a chair. So you will tell him that I would like to buy a chair that supports 70 kg load. So after he will show you a model and he will ask you to sit on that. You will sit on that chair and he will just try to know whether it is moving when you are sitting for your load, or it is taking the weight, or the legs of the chair are buckling or not. So that is, we call it as analysis. So in the analysis, what we do, we apply the load and we'll see how the chair behaves, whether it is stable or with just slight movement, it's trying to overtopping, like moving or sliding, so on so. And you know, when you take a chair, if it is my chair, it will be having the legs. And when a person sits on this, after sitting, there will be load acting. This load will be transferred to the, excuse me, this load will be transferred to the legs and then ultimately to the ground. So because of this load transfer from the, you know, from the person to the columns to the base, these columns will undergo compression. The member of this acts like a slab. The slab, it undergoes tension, and there will be different bending moments, shear forces, even axial compressions, etc. will be happening. Even the deflections will be happening in the chair. Though those will be very minor. You guys cannot see with your normal eye, but there will be some minor deflections. So all these are the things which we study under structural analysis. So in the structural analysis, where did I write? We'll study the things like, number one, the first thing is first finding the reactions, and then the bending moment, shear force, axial force. All these are the effects of the load. Even this reaction is the effect of the load. And even the deflections are the effects of the load. So under the structural analysis, in the FE course, we're gonna study the deflections, we're gonna study the bending moment, shear force, so on so, and we're gonna study the reactions. This is a one set of topic we're gonna study. And then coming to the structural design, if you take the same analogy, that is a chair, suppose if a person weight is 100 kg or 120 kg, then the seller will say, sir, your weight is a bit higher. For safety and stability of the chair, I recommend you to use so and so steel chair rather than using wooden chair. Wooden is a weak material, but steel is a stronger material. For a given load, for the safety concern, he will say, your material shall be steel. So he will decide the material there, whether it is steel or whether it is a concrete, whether it is a steel. That is a area of study we have to do. And then what we do, we take the size. Since the guy's weight is 120 kg, he will also say that I will definitely make a chair of steel, and also I'll make sure that the legs of the chair are wider and bigger, so that your load can be easily transferred to the ground. So here he will say, he will take about size, whether to take the more size or whether to take the small size. This will be decided in the, which part is it, analysis or design, material and size?
Design.
So it is design. So this is a brief summary of what is structural engineering. I'll tell you, sorry. So you can see I have collected some data for you. This, you know, the lengthy definitions is not needed for the exam. Structural engineering is a specialized branch of civil engineering. Even some of you guys might be doing structural engineering for the MS. Even after passing the FE exam, when you want to become the PE has subcategories, whether you want to become the project manager or structural designer, so on so. So this is a specialized branch of civil engineering that focuses on design, analysis, and construction of structures that support or resist some loads. So here you can see the key responsibilities of structural engineer is, in the structural analysis, he will calculate how structure responds to the loads. In the structural design, he will choose the right materials and sizes for the different structural elements. Structures and structural elements are different. Structure is a whole body, and structural elements are individual pieces of the structure, like beams, columns, slabs, the tie members, strut members, compression members in trusses, so on so. You can see what are the different types of structures that are available. You can guys name them. Okay, you guys name them. What are different types of structures available?
Dams.
Okay, dams or structures. Why they are structures? They are taking the loads. Loads of what? Water,
Water.
right? Even they will be designed for earthquake loads also. That are secondary loads. The primarily they are designed to take the water load. Okay, and then
Columns,
bridges.
slabs.
Okay, this is also
Pre-engineered buildings.
pre-engineered buildings, PEB structures. I agree. They take the loads like wind load, self load, dead load, and then roads. They will take the vehicular loads. I agree.
Towers, furniture.
Towers. I agree. Furniture. I admire your answer. Furniture or load taking structures. Then we missed one structure which we're gonna study in under FE syllabus.
Buildings.
Yeah, buildings. Okay. We missed trusses, right? They are also kind of structures. Generally, bridges are of different types like RCC bridges, arch bridges, trusses. Okay. So we're gonna study. Someone has said something like beams, slabs, columns. Are they structures or something else?
They are supporting members.
Yeah.
Of the
Element.
structure.
Members.
Structure or elements.
Yeah, they are the elements of structures. Okay, that is the thing. Now, when I come to the difference between analysis and design, you guys, as I said, it determines how a structure responds to the load. Analysis is, and the design is selecting and sizing the structural elements to resist those loads. That is the case. And the purpose of this analysis is to understand the internal forces, movements, and deformations. And the purpose of design is to ensure the structure is safe, stable, and serviceable, so on so. And what are the key tasks we do in structural analysis? We calculate the internal forces like bending moment, shear force, reactions, axial force, etc. And we compute the deflections and we study the stability. And here in the structural design, the key task we do is we choose the material as we already discussed, and we design the cross section, whether it has to be circular or rectangular, based on that. And what are the inputs we give in structural analysis? We give the inputs of loads, whether the load is uniformly distributed load, point load, so on so. And whatever the outputs we get from structural analysis, they become the inputs for design. And you guys, there are plenty of tools that are used in structural design and analysis, like StarPro, ETAPS, SAP. Our Bhavanam C2C is giving the courses for this. If you want, you can take them, and rest and all you can get it from internet, so on. So this is some. I just made a explanation how to do this analogy structural analysis for a chair. Okay, this is about the subject. Coming to the syllabus, when you see the syllabus here, the first topic is analysis of statically determinate. These are some kind of elements, beams, columns, trusses, and frames. These are the structures, these are the elements. In the syllabus, we have to analyze the beams, columns, trusses, and frames. We can study, no worries. And then the next topic is deflections of statically determinate beams, trusses, and frames. What is the meaning of deflection? Any answer?
Moving away from the original point.
Yes,
Like-
from the original.
Bending.
Instead of yes, bending. So here he said to find the deflections in beams, trusses, and frames. He mean to say, when I take the rough, suppose if it is a simply supported or fixed beam, and if there is a load acting like this, and a point load and varying load, this member will deform something like this. So this deformation and the displacements from initial location or initial point to the final point and different spots, we call this as deflections. These deflections can be either slope or it can be the displacement, that is vertical movement, or the slope is nothing but the rotation. So there can be questions to find the rotation or the slope, or to find the displacement of this member vertically down or up, so on. So even if you take a truss, and if trusses looks like this, and we have been seeing the word stability here. Can you guys say, so okay, this truss is a bit complex. I'll give you a simple truss. This is a truss. Truss is a member structure where the ends of the elements are connected by the joints. There is a support here. Now, if I apply the load here, first tell me, is it a stable structure or unstable structure?
Unstable.
Yes, it is unstable. You can think practically when you try to move this will just fall away like this at the hinges. Because if you guys recall it, I have explained you the reason in statics, I guess. Did I explain? Did you guys, any of you
Yes.
remember this? Yeah.
Yes.
So for the syllabus, even there is a stability analysis of the beams, trusses, and frames. We'll study whether a truss is stable or not, whether a beam is stable or not, whether a frame is stable or not. I'll show you a simple example. Suppose if it is a beam, and if it is a roller support, here also roller support, and I applied some load, something like this. Can you guys say whether this beam AB is stable or unstable?
Stable.
As I said, stability is something related to movement, right? If I take a load, it should not move away. It should take the load and transfer this load to the columns or the ground. Is it transferring the load or it will move away?
Move.
Is it a force acting on the beam?
Yes,
That
it's a force
keeping,
acting on. Yeah,
so that's unstable. Yeah.
yes, exactly. This is unstable, right? Because when you apply this load, it will be having some components P1 and P2. Because of this load acting here, and both are free to move, the beam will just run away. It will move away from its location, away from its pre-described location, which it fails its purpose. So it is also unstable structure. Similarly, even if you want to know in terms of this is beam stability, this is truss stability, and when you want to see the frame stability, the examples are very simple to frame. Suppose I've given the frame like this, and I'll make two rollers here. Again, it's gonna be unstable structure, provided it depends on the load actually. If the load is something like this, I can say this is a stable structure. If the load is purely symmetrical, it is a stable structure. Instead of this, if my load is something here like this, now tell me, is it a stable frame or an unstable frame?
Unstable.
Unstable frame. Why? Because since the load is acting in this direction, it will run away. The frame will run away. So this is all about the next topic, that is stability analysis of beams, trusses, and frames. I have given you very simple examples, but there are some, level 2, level 3 of how to check whether the beam or truss is stable or not. We'll see it. And then I get this is clear, and the stability analysis clear. Coming to structural determinacy. Any guess what is this structural determinacy or indeterminacy? If you recall the mechanics of materials, guess. It has something with English grammar itself. What is determinacy? No answer? I'll give a hint. You guys will answer it. Suppose if this, yeah.
Structural details.
No.
It's like, can we like if we find like doing any calculation, finding any reaction, it is solvable or not, then we can say that is
Yes,
determinant or indeterminate.
you're 50% right.
Or force on the internal members?
No. You guys are almost near. See, when I take a beam and if I apply some extra loads, what are the first things we find out in mechanics of materials or statics? Especially in statics, what do we do?
Finding the reactions.
Yes, right answer. Finding the reactions. Reactions will be acting like this. Vertical reaction at A, horizontal reaction at A, and vertical reaction at B. And no horizontal reaction here because there is a roller. So there is no restriction to movement, so there will be no reaction. Now, how were we finding out these reactions? What are the procedure?
Applying the equilibrium equation on each
Yes, perfect answer. By applying equilibrium equations. So how many equilibrium equations we have? As I said, in statics,
3.
3. Perfect. You guys remember everything, but not piling up the things. Okay. So how many reactions we have here in this case?
Trace 3.
Here 3 reactions, and we have 3 equations. Now, can we find all these 3 reactions using 3 equations?
Yes.
Yep, we can.
Yes, as per math, if we have 3 equations, we can easily find 3 unknown reactions. So then I will say this structure as determinate structure. Got it? So determinacy is nothing but finding out whether the structure is determinate or indeterminate. As simple as that. Suppose I will give you one more example. Like this is a proper cantilever. What is proper cantilever? Any guess?
16. No.
I think
One
the
side
load is
is
act on
fixed.
the
Fixed
opposite
at
side.
one end and other end.
Yes, you guys are almost right. Proper cantilever is a cantilever with a prop support. Prop support is nothing but a roller support that is placed at the other end. Now, if this is my proper cantilever beam and I apply some loads like point load, even it can be moment or it can be uniform distributed load. Now, guys, tell me what are the reactions at A and B?
A have 2
At
of
A, 3
A have
reactions.
3, B 2.
Perfect. A as 3, I agree. Vertical reaction at
And
A,
B at
horizontal.
1.
Yes, movement at A. B is 1. Someone said 2. There will be no
Yeah,
2,
1.
only 1. Okay. So total number of reactions, how many?
4.
4 number of reactions. But how many equilibrium equations we have?
3.
It's
3.
always 3 in 2D case. So can we find all the 4 reactions or we can't?
No, we can only do 3 reactions.
Yes. So we cannot find all the 4, right? That's why we call it as indeterminate structure. And what is this degree of indeterminacy for the structure is the number of reactions which we cannot find with the available equations. Here, tell me how many reactions we cannot find with the available equations?
1.
Just 1.
Just 1. Then we call this of degree of static indeterminacy is 1. So this is one type of topic we have in FE. We'll study. Similarly, for trusses and for frames, we have some so and so formula to find this degree of static indeterminacies. We'll see them in the syllabus. In today's section, I'm just summarizing what is there in the subject. So I always believe in working from whole to part. Let us learn what is there and then we'll see one by one what is the details. And then this is clear, clear. Okay. Something here, column analysis, that is buckling and boundary conditions. It is very simple. Can you guys tell what is this buckling of column?
Breaking.
Is it breaking or something different to breaking?
Failure of the structure element
Like
or column.
deformation of the structure.
Yes, deformation, I agree. It's an answer. It is the answer.
Failure before breakable
It happens
point.
only on columns.
Buckling happens only on columns. Anyone object to this or add on to this? Any conditions for this? Conditions apply? Someone, our friend is saying buckling is a type of failure that occurs only in columns. You're right. I can't say you're wrong. You're right. But not only in the columns, in any compression members. That need not be column. If you take a beam, like a structural steel beam, the top member will be under compression. If the loads are very high, the compressive loads will be very high on the top flange of I section. The flange will undergo local buckling. Even though it's not a column, it undergo local buckling. Can you connect to my explanation?
Yes.
Yes, sir.
If compression members goes
Mm.
bending on the sideways,
Yeah.
then we can call as buckling.
Yes. So buckling is not confined to columns, but here he is discussing about the columns. What is buckling is, I already explained you in statics, if I remember statics or mechanics. Suppose if this is a column and I apply some load here. If the load is very, very high, the column can fail in two ways. The first way, it can fail by crushing. The column will undergo crushing and it will break, the material break. And some other way is, if the column is very, very long, suppose very slender column, instead of buckling, crushing, it will undergo buckling. Buckling means it will undergo bending like this. Got it? We call this as buckling. It is also a failure because it failed to serve our purpose of carrying the load vertically. It is failure, but just it is structural failure. We call this failure as buckling. It is also a failure because it also failed to transfer the load, but we call it as crushing. So whether a column undergoes crushing or buckling, it depends on something called dash ratio. What is that ratio?
Slenderness.
Yes. It's very simple thing that the terms look very technical. If you see the grammar, English grammar, slender member is nothing but the one that is very thin. Obviously, by common sense, if a thin member is underwent with a compressive load, so instead of crushing, it will obviously undergo buckling, isn't it? Doesn't it look obvious? The thin members undergo buckling, right? Yeah, that is about some brief summary about
And
the column. Yeah.
for buckling, it's going it always buckling we can experience in suddenly, right?
Need not be. If it is a structural steel, the buckling can be time taking. To be precise, crushing is sudden.
Got it.
And it has different combinations. Suppose if it is a concrete prefers to crush rather than buckle. And if it is a steel will obviously, it is very strong material. It will not crush, it will buckle. You know, they based on material, based on slenderness ratio, it varies. And this is clear. And what are the boundary conditions of column means? It's like the top and bottom of the column will be fixed. Either it is rigidly fixed, or it is free to air. If you take into day-to-day columns, I will say, obviously inside the buildings, the columns will be like fixed at top and bottom. They will act like fixed edges. This is one kind of fixity of a column, one kind of boundary condition. I can say there can be columns in nature which are like fixed at the bottom and free to the air. Can you give one practical example? Anything from nature or anything from your day-to-day life where the columns that are fixed at bottom and free at top. Very easy.
Water tank.
Water tank? No. Water tank is very
Yes.
Yes,
Electricity
please.
towers.
Yes, please. Towers.
Electricity towers.
Yeah.
Pole.
Electricity. Yes. Pole is the right answer. If it is a light pole, there is simply some small light here and it is fixed here. It will be left like this. Even if you take the natural materials, like something you guys know, if it is a tree, the tree has fixity at the ground. It's like all the roots will be fixed here. This will be like fixed connection and the top connection will be free. That's why if there is a heavy air, the trees can bend like this. If the air is very heavy, like what we call cyclone, so and so, it will break also. So the column, different boundary conditions will be there, like fixed, pinned, pin, fixed, free. So those are, we call it as boundary conditions. So this is a thing. And coming to the next topic, that is elementary statically indeterminate structures. Generally, for FE case, we don't have statically indeterminate structures. They are difficult to analyze because they want additional equations other than equilibrium equations, which we call as some other equations. Any guess?
Equilibrium equation?
No. Equilibrium equations are used to find the reactions in determinate structures. But in indeterminate structures, we use equilibrium along with some other equations. If you remember them, I told you something. We call them as compatibility equations, right? So using compatibility equations, we'll solve the indeterminate structures. But since we don't want to make the syllabus difficult, they will say just elementary statical indeterminate structures. Like indeterminate structures only, they are very simple, like degree of static indeterminacy is 1. By using one compatibility equation, we'll get the answer. There is one topic for that, we'll study that also. So this is clear. And coming to the next topic, loads, load combinations and load paths. It is very simple. You guys know very well what are the different types of loads acting on a building or any structure. Name me some loads.
Point
Dead
load.
load,
Live
Live
load,
load,
dead
dead
load,
Mm-hmm.
wind load,
Perfect. Wind loads,
static
Thermal
load.
load.
static loads, agree.
No, the ground would be the template. Earthquake would be a moment.
Yes, it's a seismic loads. We call you
Yeah.
can say them as seismic
This
loads or earthquake loads. Even if you take the dam, we call it as hydrostatic loads, that is water loads. And even if you design for a building in the US, if you design for a roof, we take the snow loads, right?
Yep.
So
yes.
there are different types of loads. And what is this load combination is, on a building, it is not always needed that all the loads act at once. In some season, there will be only live load, dead load plus snow load itself in winters. And in some, monsoons, there can be wind load, live load plus uh, dead load, live load plus wind load only. There may not be snow loads. So load combination talks about the different combinations of loads, and some codal provisions prefer to use some load factors like 1.2, 1.1, 1.3 that we will study here in the load combinations. And coming to the load path, you guys know it very well. When you sit on a chair, your load will be transferred to the plate of the chair, and from the plate, it will transfer to the legs of the chair, and from the legs, it will transfer to the ground. So the transfer of load from one element to another element of a structure, we call it as a load path. So we'll study about them. And then we guys know what is dead load, live load, lateral load, and something we have here, influence lines. So this influence lines is something related to moving loads. Where can we see moving loads, especially? Very simple. Where do we see moving loads on which structure?
On roads.
Yes, on
maybe on
roads.
bridges.
Apartments.
Yes, exactly, on bridges. So when we talk about the moving roads for FE exam for structural engineering, we have 1 mark definite question, that is influence line diagram. We call it as influence line diagram. In short, we call it as ILD. Like I said, the bending moment diagram, shear force diagram, which we studied with some tips and tricks. We have influence line diagram. Again, it has some tips and tricks. If you learn this, we can say we can get 1 mark for sure. What is this influence line diagram? I'll give you just brief summary. If it is a simply supported beam, suppose it is a bridge. There is a bridge, and if it is a column here, this we call these columns in a bridge as abutments, and the rest is ground as it is. This is a ground, this is a ground, and water is flowing like this below the bridge, and vehicles are traveling from one end to another end. Suppose if a vehicle is traveling from here to here, at different locations of this vehicle. Suppose when the vehicle is at location 1, at 2, at 3, at 4. And suppose the ends of this beam or the bridge is A and B. When the vehicle is at A, the reaction at A will be some value. It will be like 10 kilonewtons. When the vehicle has reached the location 2, this reaction at A, now I place my vehicle from here to here. When it has traveled to here, now the reaction at A, will it be same or it will be different? Any guess?
Different.
It
Different.
will be different. So reaction at A, when the vehicle is at position 2, will be something different. Let me mark it as 7 kilonewtons. Now reaction at A, but when the vehicle has traveled from here to here, again, this reaction will be something different. Let me take it as 5 kilonewtons. The same funda applies here. When the vehicle has finally crossed the bridge, the reaction at A, actually speaking,
Zero.
it will be 0 because entire load is transferred from here to here. So now, when I draw a diagram and I mark this as horizontal reference line, and with the y-axis, I mark it as the magnitude of the reaction at A. And if I plot at different locations like location 1, location 2, location 3, and location 4, and if I mark those points, it was 10 kilonewton here, 7, 5, 0. And if I join these lines, actually speaking, it will be a straight line. Anyway, if I draw this line connecting this, then we call this line as influence line diagram for reaction at A. So ILD for reaction at A. This is how we draw influence line diagrams. Influence line diagrams can be drawn for different reactions, can be drawn for bending moments at a particular location. It can be drawn even for the shear force. It can be drawn even for the trusses. It can be drawn even for the frames. As keep on going, the difficulty of the topic gets, increased. But for the FE case, we first emphasize on beams and then we'll go slightly about the trusses and we don't go for frames. Even trusses also a bit difficult, but I will try my best to let you understand the topic easily. And then coming to the next thing, that is tributary area. It's very simple again. Suppose if you're sitting on a chair, these are the 4 legs of the chair. When you sit, the pelvic muscles will be there, pelvic bones will transfer the load at 2 points. These 2 loads will be transferred to the plate. The plates, how this plate will take these loads in terms of they will split this load on some distributed areas. Like from this portion to this portion, there will be load transfer from here. Some other point load will be transferred here. Another load will be here. Another load will be here. So this load will be shared by the plate in different shapes like rectangular, triangular, trapezoidal shapes. Such shapes we call it as tributary areas. We'll study about them again. And coming to the design part, you can see the analysis part is a bit bigger. There are 1, 2, 3, 4, 5, 6 topics. And the design part, we have only 2 topics. But to be very precise, it is also bigger content. The first thing is design of steel components like structural steel. There we will study what are the codes to be used, and then we design the steel beams, steel columns, and steel tension members and steel connections. So you guys might have seen the steel beams, some steel columns, and steel connections. Where do you see? Someone has said some structure example. Where you can see. Yes, please.
Bridges,
Yeah, steel bridges, I agree.
steel bridges or towers, buildings.
Yeah, if you take the pre-engineered buildings, and everywhere we will see only steel beams and steel columns, so on so. And the second design is reinforced concrete components. So here also we'll design RCC, beams and columns. It's very simple. I will show you. This is about the syllabus, and I have briefed you about the subject. Now let's see the last thing, how the handbook looks like. So when I see the handbook, that is 10.5, it has some pages, like around how many pages it is? It's around 22 pages in the handbook. Not entire everything is mentioned in the handbook. There are some topics skipped. Like I will say, the analysis part, the syllabus is more, but the content they have given in the handbook is less. And for the design part, they have given each and everything that is there in the syllabus. So you need to panic for the design, even though the structural design is a bit tougher topic, but the last pages, they have given you all the required data like tabular data. They have given you figures for easy understanding. They have given you some charts to get the quick answers. So we'll practice plenty enough. They have given all the formula that are needed. But I can say you guys, even though the design looks very clumsy, no need to use any of this, uh, tedious formulas. Every answer we can get from the tables. So when you practice enough, we'll get this, how to use the tables and charts. And then if you see the topics clearly, they started the subject with influence line diagrams, which I have said you. And then they have explained you something called beam stiffness and carryover moment, so on so. And then as I said, they have given some methodologies to find the deflection in trusses. And they have given some methodology to find deflection in frames. And then, as I said, they use one of the methods for finding indeterminate structures, reactions in indeterminate structures. And then, as I said, there will be some topic related to stability and determinacy. There are some formulas like so and so number of members, number of reactions, number of joints. We'll see that. And coming to the design, they have given some topic related to the different types of loads and load combinations. And they have given some formula for load reduction factor, so on so. And then they have jumped into design of RCC members. And yeah, in the RCC members for the beams, they have designed for the bending moment and shear force, so on so. This is what the handbooks looks like. Yep, this is the end of the session for today. If you have any doubts, you can ask me.
So, would we be going into deeper calculations for these topics?
Yes, we are going into pure calculations.
Okay, so the
Uh,
exam would be based on pure calculations for this section.
Yes, for this. Out of all 14 subjects, I can say this subject has more technical things. Like we have to get into math, we have to go into calculations, we have to use the designs, charts, so on so.
So
Mm.
when I'm preparing, because now what
Mm.
happened is that as I'm progressing into different classes, I'm forgetting what the ones that I was doing before. Now I want to do the whole thing again as a revision,
Mm.
post the classes. What should be the order that I should follow in order to have these done step by step?
For this subject, you're saying for this subject especially, right?
Yes, including this subject, because what's happening like with consecutive classes, I'm forgetting the one that I had previously done that includes like geotechnical or these things,
Mhm.
probably because
Mhm.
lack of time and lack of practice.
Got it, got it. When you go to the exam, the questions, when you see a question, you are saying how to recall my brain from which topic I have to enter. You are just saying
Yeah.
that, right? So
Yes.
since the topics are very vast, okay. For this, the first approach is you have to analyze your brain. You have to think your brain as a system, like a computer. You assume that you have a FE folder in your brain, and in the FE
Okay.
folder, you assume like there are 14 folders, subfolders for each subject. That is step 2. In the step 3, in the each subject folder, at least you have to remember what are the topics there. In the step 3, there should be again subfolders of topics. If my brain go into structural, suppose mechanics of materials, there should be a subfolders for stress, strain, Poisson's ratio, and even I am trying to recall now. Like stress, strain, Poisson's ratio.
More
What?
circle.
Yes, more circle, principal stresses. Then we have studied about the pressure vessels. So like this, you prepare a flow chart. Uh, if you have such difficulty, I suggest you to always keep watching the syllabus paper. Suppose this is a syllabus of this. You just print this 3 pages and keep watching this. Just memorize this 3 pages. Then
Okay.
it will make you the things a bit easier for you.
Okay, and when I'm preparing, okay, when I'm
Mm,
preparing, okay, when I'm doing all over again to
mm,
prepare for the exam, What
Okay.
what should be the order? Because these are not exactly the same order that I should be going into, right?
Got it. I understand this. Coming to the structural subjects, there are how many structural subjects like
40
statics? There are 14
statics.
subjects. Coming to structural, there are statics, dynamics, materials, and then mechanics of materials, and then structural engineering. So what I suggest is take this as first subject. Statics deals with all the basics, like what are the forces, force components, resultant of forces. Okay. And then
Okay.
you study the dynamics, where it deals with the motions, like when a body is moving, acceleration. To be frank, this dynamics it can be studied with any flow. It can be done before this or after this. So after statics, you better study dynamics, and then you study the materials. Here, you will get clarity on what is steel, what are the different properties of steel, like toughness, hardness, ductility, brittleness, etc. And then go for mechanics of materials. You can see this is materials and this is mechanics of materials. So there already you will cover the some basics about materials, and then you'll jump into mechanics. The mechanics is related to the statics and dynamics, and the materials is related to this. When you cover these three, you will you will form a foundation to further subject mechanics of materials. And then when you
Yes.
complete all these four subjects, it will form a foundation to cover each and everything, like concrete design, steel design. There we will again come back to these subjects itself. So you follow this trend, it will be easy for you to quickly cover the syllabus, right? This is for
Yes.
structural subjects. Coming to the water subjects, how many subjects we have for water? Can you guess?
Fluid mechanics
Yeah.
Hydraulic.
and
Mm.
hydraulics.
Is it water resource engineering, I guess?
Yes,
Yes.
water resource engineering and waste. I think waste management.
Geotechnical engineering.
That is okay. Mm. So
What is
related
your
to, let me see. The first is not water. It is not water. It is not water. Not water. No, no. This is one water. Water resources and environmental engineering, and then structural, geotechnical, transportation, construction. So coming to these two subjects, you first study the fluid mechanics. I remember in the fluid mechanics, we studied properties of fluids. What is density? What is specific gravity? So on so.
Yes.
So if you study this, the basics will be helpful for this subject. This is the order for this and order for this. And coming to the before all these subjects, I suggest to go the first subject, that is what I can say, mathematics and statics.
Mathematics,
This, yeah. Before then you do the maths. So because everywhere you do the maths in all the subjects,
Yes.
right? And then ethics and professional, this is some other subject. And engineering economics, it is related to the maths. So this has to be processor, successor. You like in project management, we have preceding activities, succeeding activities. Okay.
Yeah.
And then surveying. Surveying is also, it's a general topic which is related to basic math, summations, subtractions, so on so. And then
Yes.
geotechnical, it is also an independent topic. It is a self topic, so it can be studied anywhere else, not an issue. It is a general topic. It is a general topic. You can study them any way you want. You first covers maths, and then if you want to cover the structural subjects, the order you know, so on so. That is the case.
Yes. Okay.
Okay.
Thank you, though. Thank you so much.
Yeah, my pleasure.
I can do surveying, then traffic engineering, and then transportation engineering, and then geotechnical. That would be a good way to go, right?
Yeah. Again, you know, to prepare out of bunch of subjects you have said, the first thing is, I believe, one more funda. Eat the frog first, which means that if you're eating something, eat something which is not tasty. So if you're not good with some subject, you just read it first. You cover it first, so that all your patience will be went into that, and you will grasp the thing easily.
Okay.
Yeah. And second thing is, eat the thing which has more weightage.
Okay, then I can skip geotechnical because I'm not really good at it, or I don't see it as an importance on the weightage of points.
How much weightage it has? It has 10 to 15 marks.
Yeah, but I'm thinking I could do perfect on structural and then transportation. So I can have a little bit of gray area with geotechnical.
Okay.
So
Yeah,
I
but
can concentrate on the other
mm.
fours and I can have those organized.
I agree with
Chandra,
that. Yeah.
I have a quick question and before I leaving, I have an
Yes,
exam
yes.
scheduled on August 14th, and then while
August
I'm
14th.
preparing the subject, the materials one especially I couldn't find in the I'm not exactly where I should find that material topics in the handbook. Do we get anything on the handbook on the material part, or else we should need to be figure it out by own?
Material, it's there in handbook. It's with some other name, like it's there. I'll show you. The subject is not at heart, but I'll share you the notes since your exam is nearby. And coming to the materials, it's with the name matter, I guess. It's with the name matter. Yeah, you can search with material science and structure of matter, like from page number 118.
I'm writing down because while I'm looking the syllabus and I'm looking for the same word that where you could match in the handbooks, and then it's very hard to find for me.
And to be frank, the content for materials in the handbook is very less.
Yeah, that's what I was
Yeah,
experiencing.
if you say the 117, I will show you our notes for materials. Syllabus for materials for civil engineering is very less, like concrete and asphalt, and then concrete, asphalt, wood, so on, so on, so. I'll share you the notes through the website. I will ask the team. Even I myself struggled a lot to gather the content. It's not there in the handbook. I will share you. Okay.
Okay. Thank you.
Thank
Okay.
you.
Thank you.